machine translation architectures work. MT architectures have undergone many developments since the 1960s and are now a household tool for modern communication. But how do these approaches actually work? In general, there are three major machine translation approaches: rule-based, statistical, and neural. Rule-based machine translation architectures were the first to be developed and use a simple form of search and replace. First, each word in a sentence was translated using a large dictionary. Then, the translation was adjusted by applying long lists of grammatical rules for each specific language pair. Thanks to such grammar rules, words were placed in the correct order, verb forms were corrected for tense and aspect, and nouns were adjusted for gender and number. In rule-based MT, a new rule must be created for every single difference between two languages, and for every different language pair. One important benefit to this architecture is that it provided more control over the translation process. If there is an error, it is relatively easy to troubleshoot and adjust the rules. However, writing the rules requires extensive linguistic knowledge and can be very costly in terms of time and manpower. Rule-based methods also struggled with ambiguity or non-literal meaning, for instance with homonyms or idioms. As computers became more powerful in the 1980s and 90s, statistical MT became the new gold standard in machine translation. These architectures were based on the idea that computers are good at processing a lot of data and running lots of calculations really fast, and so translation technology should work to those strengths. Statistical MT uses large electronic collections of texts called corpora as their training data to find patterns and calculate the probability that a particular translation is correct. Statistical machine translation proved to result in much better translations, especially for languages with a lot of available data. Finally, neural machine translation uses artificial neural networks and vector spaces to predict the right translation. In 2016, Google Translate shifted from statistical machine translation to neural machine translation, providing the world with free access to high-quality translation output for many different languages. Neural approaches have quickly become even better than statistical approaches, as a result of which most architectures used today are now either neural or a hybrid approach that combines the strengths of neural and statistical methods. Thanks to deep learning, neural machine translation approaches learn from every new example that is translated, not just from the training data. They place each word in a language in a vector space, a multidimensional space in which words that are strongly related appear closer together, and words that are unrelated appear far apart. This is why neural approaches need words in the context of a sentence to calculate the distance between words and determine which meaning is used and thus which translation is needed. While neural MT works really well, it is a bit of a black box system, meaning that we don't necessarily understand all the internal mechanisms that generate the output. Translating the same sentence on different days can return different results for no apparent reason, and neural approaches are known to sometimes produce fluent but incorrect outputs, such as hallucinations, which are translations that are completely unrelated to the text being translated. Regarding both statistical and neural MT, it is important to realize that the architecture works on the basis of statistics and algorithms and does not understand word or text meaning the same way a human does. The architecture has no world knowledge and does not know about cultural differences or humor or taboo. It calculates the likelihood that word A is followed by word B and not word C, and does not take into consideration whether this makes sense or is appropriate, which is exactly the reason why in professional contexts, machine translations are normally checked and corrected by human post-editors before they are used. Thank you for watching this video on the theory behind machine translation architectures. If you would like to learn more about machine translation literacy, please visit our website. Thanks for listening.